Today we are going to discuss about work energy equation for connected bodies. What is connected bodies? You see in this figure we have two types of blocks are there. Number one is mass M1, another one is mass M2. Here these two blocks are connected by means of a string. So if this body moves with some velocity, automatically this body also will move, because since it is connected by each other by means of a string through a frictionless pulley. So let us consider that two blocks of masses M1 and M2 respectively, and it is placed on a rough surface and connected by means of string over a frictionless pulleys. So since it is a rough surface, definitely friction will induce. So let us consider one thing. So since the motion is in this direction, assume the motion is in direction. So let us consider the motion in this direction. So automatically friction will develop opposite in direction, that is F1, and assume that the velocity of the block 1 is V, initial velocity is U, and final velocity will be so let us consider the initial velocity of the block 1 is U1, final velocity of the block is V1, and block 2, similarly block 2 U2, V2. Since these two are the connected bodies, I can say that U1 is equal to U2 is equal to U. Since these are connected by each other, so velocity of the both blocks are same. Similarly, V1 is equal to V2 is equal to V. And similarly, the displacement, that is distance covered by the block 1 is equal to distance covered by the block 2, because these two are connected by each other. So S1 is distance covered by the block 1 and S2 is distance covered by the block 2, which is equal, that is S. Right? Masses are different, but those two are connected by each other. That's why the velocities and displacements of both the blocks are equal. Just a kind notification. Similarly, the block 2, the motion of the block 2 will be assumed like this. Since this block is moving up the plane, this is also moves up the plane. So due to motion is moving upward, then frictional force developed in opposite in direction, say that is F2, right? So this is the initial conditions of both the bodies. So we have to remember one thing. We know that work energy theorem, work energy equation or theorem. So work energy equation, according to work energy equation, work done is equal to change in KE. KE means kinetic energy, that is final kinetic energy minus initial kinetic energy. So for block 1, assume for block 1, the work done is equal to, work done W1 is equal to, for block 1, half M1 V square minus U square, right? So work done nothing but, here F is the force applied on it. So work done is equal to force into plus F. Since it is positive, because it is moving towards the motion, so motion is in this direction, work done also same direction, so F is positive. But F1 is opposite to the motion, so that is minus F1, right? And displacement of the body is S. That means S1 is equal to S, is equal to half M1 V square minus U square. Actually V1 square minus U1 square, since U1 is equal to U, V1 is equal to V, so directly I substituted like this. So let us consider this is equation number 1. So why we are considering only horizontal forces? Because motion is in horizontal direction, so we need to consider forces in horizontal direction. And one more thing, here we have a string, so definitely string have some tensions T1 and T2. Since this is a single string, so T1 is equal to T2, and this is a tension. So if you substitute the tensions T1 is equal to T2 is equal to T, automatically it will be cancelled. So no need to consider tensions in the string while the two bodies are connected by each other. So T1 T2 will get cancelled since these are connected by a single string. Underline, it is a single string, isn't it? So that's why we are not considering tension T1 and T2. Similarly for block 2. For block 2. So similarly for block 2, we have only one force, that is F2, that is opposite in direction. So similarly work done applied on the body. That means work energy theorem applied on the body number 2, then work done is equal to W2 is equal to half M2 V square minus U square. Here also we need to substitute V2 minus U2. Since U2 is equal to U, V2 is equal to V. So that's why I am directly substituting V square minus U square. Similarly, work done along the horizontal plane, that is along the motion of the body, that is minus F2 into S2, but S2 is equal to S, so that is S is equal to half M2 V square minus U square. That is equation number 2. Since these two bodies are connected with each other, so work done by the body 1 and work done by the body 2 should be added by each other because these are connected by a single string. So adding equation 1 and 2, since these two are connected by each other, so plus F minus F1 into S plus minus F2 into S is equal to half M1 V square minus U square plus half M2 V square minus U square. That is change in kinetic energy of the block 1, change in kinetic energy of the block 2, right? So this is plus F minus F1 plus minus F2. So let me take S common, that's why it will comes like this. So is equal to, you can take common half V square minus U square. So you can get half V square minus U square into M1 plus M2. So you can say that what is this F minus F1 minus F2? This is nothing but sigma Fx. So that is X forces along X direction. Since it is X direction, so all the forces are in X direction. That means net forces are in X direction. So I can say that sigma Fx, this is nothing but sigma Fx into S is equal to, I can say that this is nothing but total kinetic energy, right? This is nothing but total work done, that is equal to total kinetic energy. If n number of masses are acting on it, you simply substitute half into V square minus U square into M1 plus M2 plus so on plus Mn. N number of forces. Here in this example we have only 2 blocks. If we have 4 blocks, similar piece of formula can be used to solve it. Similarly, half M V square minus U square into M1 plus M2 plus M3 plus M4. So that means this is nothing but total work done. LHS is nothing but total work done is equal to RHS is nothing but total change in kinetic energy. Total change in kinetic energy. This is the statement and that is the proof. And work energy theorem for the connected bodies is equal to total work done by the bodies, by all the bodies is equal to total change in kinetic energy of all the body. So that is work energy equation for connected bodies. Thank you.